Now we're going to take a look at x-intercepts. The first question we asked was, well, can there be an x-intercept? Yes. Do we always have an x-intercept? No. So the second question, how can we find the x-intercept? Well, here we have a table, and it's very similar to when we looked at finding our y-intercept, except now we are looking for the point where y is equal to 0. That is your x-intercept. So on your table, you are not looking at the x column, you are looking for the point where y is equal to 0. So going down my table, y is equal to 0 here. So my x-intercept on this problem is 4, 0. Same thing when you're looking from a point. You're really looking for the point where y is equal to 0. So if you have a ordered pairs listed out, label your points, x and y. Wherever y is equal to 0, that's going to tell you your x-intercept. On a graph, it's not much different either, except now we are looking for the point where the graph crosses the x-axis. This is the point where y is equal to 0 and the line crosses the x-axis. So looking at our graph, we see that we have a line and it's going down. Now what we talked about with y-intercept is the point where the line crosses the y-axis. We are looking for the x-intercept. So we are looking to see when this line crosses the x-axis. This point happens at 4, 0. Notice the y value is equal to 0, and this is the point where we cross the x-axis. So this is our x-intercept. Is there an easier way or another way that we can find the intercepts? Of course. We're going to look at the equation 3x plus 6y equals 18. I know we haven't seen an equation like this before, but we'll get there. So, to find the x-intercept, we're just going to use what we know. We know that the x-intercept happens when y is equal to 0. So, I'm going to plug that value in for y. So my equation was 3x plus 6y equals 18. So I'm just going to take out the y and plug in 0. So my new equation is 3x plus 6 times 0 equals 18. 6 times 0 is just 0, so that cancels out. Now I have 3x is equal to 18. Divide both sides by 3, and x comes out to be 6. So now that I know what my y value is, and I know what my x value is, I know that my x-intercept is at 6, 0. So, as a summary, to sum it all up, the x-intercept represents the point where the dependent variable is equal to 0. We said that it's when y is equal to 0, y is dependent, so dependent variable is equal to 0. In a real-world problem, this can be written in different ways. For example, the y-intercept of our graph could represent the time that it would take to finish a race. So for example, if this is us running and we are 8 miles away from the finish line, how many hours do you think it would take us to run and finish the race? Well, that means that our distance, which is here, would have to be equal to 0. When is that equal to 0? After 4 hours. So, in the example above, the x-intercept could represent the time it would take to finish the race, where distance, y, is equal to 0, and time, x, is equal to 4. So our x-intercept is at 4, 0.